this last type of factoring has a special name. Factoring a difference of squares. And the name itself is to help give you a hint on how to recognize it so that you can factor it quicker. So the idea is if you can recognize a difference of squares, then you can factor it quickly. And how do we recognize a difference of squares? Well, it has the word difference in it, which means subtraction. Differences of squares always have a subtraction, where the first number is a square and the second number is a square. So for example, x squared minus 9 is a difference of squares. We have the difference in between them, and x squared is a square, and 9 is a square. Because 9 is 3 times 3, and x squared is x times x. Now, most people get stuck with factoring differences of squares because they look at this initially and say, I don't know how to make this work. If every single time a person had written a difference of squares like this, you would have no problem factoring it. But nobody writes 0x when they write, they just say, if there's 0 x's, doesn't it just make sense to write x squared minus 9? Like it makes way more sense to not write that 0x. But if I wrote it this way, I guarantee you could factor it right away. Because now it's like our factoring from before. What's the only way to get your first ones to be x squared? This is like level 2 factoring, x and x. How can you get 9 so that your outside and your inside give you 0? Can you think of something that would work so your outside and inside give you 0?
Positive 3 multiplied by negative 3.
Positive 3 and a negative 3. And you see that that gives you 0. Okay? But what makes differences of squares unique is that 0 is gone. So people don't think of it as a trinomial because there's only 2 things, and then they get stuck. But if they recognize this as a difference of squares, a difference of squares always has the x and the x, and it's a square, so it has to have a 3 and a 3. And if you make one positive and one negative, your outside and inside will always make the middle go away. And so factoring, if you recognize a difference of squares, factoring them is super easy because it's always the same number that gives you this, the same number that gives you this, 1's plus 1's minus so that your outside and inside cancel out, and it works out perfectly. So you recognize a difference of squares when there are only 2 terms, both of which are squares, being subtracted. So again, if I do another one, x squared minus, let's pick one what I feel like today. Should we go really high, like 144? Do you recognize 144 is 12 times 12? So then this is going to be x and x, 12 and 12. One's going to be plus, one's going to be minus. And you see that your outside and inside would cancel each other out and you have no x's left. So factoring a difference of squares, in my opinion, is one of the easiest things to do if you recognize it. So try these 3. Or is there even more after that? Check my notes. Oh, there's more, but we'll just start with these 3. First one, x and x. Last one's a 4, 2 and 2. 1 plus, 1 minus. one, x and x. Last one, 11 times 11, 1 plus, 1 minus. Doesn't matter if you put the plus first or the minus first. X and x, 6 and 6, 1 plus, 1 minus. Again, just like regular ones, you should always multiply it out after you figured it out to make sure it matches. Do your first ones in this one. Give me an x squared. Yes. Do my last ones, 6 and negative 6, give me negative 36. Yes. Do my outside and inside cancel out completely? They do. So now we can make a little bit harder differences of squares with numbers in front. But 9 is just 3x and 3x, and 144, 12 and 12. And 1 is plus, and 1 is minus. So I recognize the difference of squares, and I factored it completely right from the beginning. However, this is where you're going to make the mistake. Always, and I should say it every single time, even though I do it in my head, but you guys don't notice it when I do it in my head. Do you see that there's still a common factor in the first one, and there's a common factor in the second one? What's in common between 3 and 12? A 3. So that means I could pull it out, leaving me with an x plus 4. Same thing's going to happen in this one. I could pull out a 3, leaving me with x minus 4. With this and our final answer, we would put 3 times 3 together, because what's 3 times 3? 9. So I'm going to write that out in front, leaving me with x plus 4 and x minus 4. Which means anytime that there's a common factor afterwards, it means you could have factored out a common factor right from the beginning. But I actually think in this case the green method is harder. How many of you knew 9 times 16 was 144 off the top of your head? Feel free to say, yeah, no, I did not know that. It's usually not something that, when people see 144, what do you think they see quicker, 12 times 12 or 9 times 16? 12 times 12. Absolutely. So I actually think in this case, right, like earlier I reprimanded some of you and I said, you made it harder. I think in this one, the black way is easier to see. But if you had seen the common factor of 9 and took it out, then the x squared minus 16 is a difference of squares. So x and x, 4 and 4, 1 plus 1 minus. We get the same answer. But I think in this case, it's easier for your brain to do the black way. But where do people go wrong in the black way? They stop right here and don't check for common factors. So we need to look for that common factor all the way through. I'm going to draw a line here and switch colors because we're running out of room. 25, a perfect square. 49, a perfect square. Okay? So one of the things that start to notice a lot in this unit is your mental math has to be strong. So this list right here of these perfect squares, you kind of have to know them. So if your perfect squares are like, I mostly know them, in your free time, don't always go straight to your phone. Take a little bit of time to be like, okay, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64. Practice those a little bit here and there. It's going to help you a ton. Because when we get to these questions, you need to recognize right away, hey, 25, that's 5 times 5. 49, that's 7 times 7. I have a difference. Could this be a difference of squares? Well, it would be 5x and 5x to give me 25x squared. 7y and 7y to give me 49y squared. 1 plus, 1 minus. Do a double check. Do any of them have common factors? No, I'm done. So again, our mental math skills help us recognize things. We give this a name to help you know how to do it. If you can say, this is a difference of squares, then your brain will be like, I know how to factor that. If we don't know what it's called, then our brain hasn't thought about it enough yet that we're like able to use this strategy. With the 100 and the 64, they have a common factor. 164 are also both perfect squares. So I actually don't mind if you choose either of these methods. If you do this right away, you'd get 10a and 10a, 8b and 8b, 1 plus, 1 minus. Or, what's the biggest number that can divide both 64 and 100? Is a 4, leaving you with 25a squared minus 16b squared. So for you, I want you to look at this question and ask yourself, which do you see as easier? Do you see it easier taking out the 4, or do you see it easier as doing the difference of squares? Then, if you saw the difference of squares, can you see that there's a 2 in common in here, and a 2 in common in there? If I take a 2 out of this one, and I take a 2 out of this one, I'm going to put those both together, I'm going to get a 4. If I take a 2 out of this one, I'd be left with 5a plus 4b. If I take a 2 out of this one, I'd be left with 5a minus 4b. And if you took the 4 out to begin with, now I look and say 25 and 16 are both perfect squares. So this is a difference of squares, can be 5a and 5a, 4b and 4b, 1 plus, 1 minus. There's no right answer to this one. This is totally preference. If you like the left side, the green side better, raise your left hand. If you like the right side for you better, raise your right hand. Everybody should have a hand up. Which one you like better?
That's good.
Yeah, I kind of see this first too. Probably again because pulling the 4 out of the 6 is the 4 pulling out of the 64 like that took a little bit more mental math than you wanted. I think that's why I like the green method too. Is 5 a perfect square? No. So we can't do perfect square factoring here. However, this one, can you see that you can pull a common factor of 5 out? So this might be all this question is a common factor. I pull out the common factor, but then I always look, after I pulled out a common factor, at what's left. And what's left is a difference of squares. So we can keep going here. Plus 10 and minus 10. And then we get to the classic on-test, on-quiz question, guaranteed to catch some of you. The classic x to the 4 minus 1. I remember getting this. My teacher caught me on this one when I was in grade 10. I remember getting my quiz back and like, oh, gotta be kidding me. I got that one wrong. So the question is, will you get it wrong? I think I should let you try it on your own. Cool. Maybe some of you want to become math teachers. And you're like, my math teacher got this one wrong, so I want to get it wrong too, so I can become a math teacher. But your math teacher did get it somewhat right. So you can't just write down anything if you want to be a math teacher. You have to get it somewhat right, but maybe not completely. I'm going to erase this just so we have more space. Is this a difference of squares?
Yes.
It is. What times what makes x to the 4?
X squared.
X squared and x squared. And what times what equals 1? 1 plus, 1 minus. How did you do? Awesome. That's what I did. Perfect. But it's not completely right. Because this makes another difference of squares. X squared is a square, 1 is a square, so we can keep going. This is not a difference of squares. There's nothing you can do with this, but this one is x and 1 and 1 and 1 plus and 1 minus. On my quiz back in grade 10, I wrote the first line and thought, nailed it. But then there was another difference of squares hidden inside of it. What if I gave you this question? To start with, do you see that you would get an x to the 4 plus 1 and an x to the 4 minus 1? And then have a difference of squares again, and then have a difference of squares again. Right? If I really wanted to, oh my goodness, let's see, what should I do? What should I do? Should I go all the way up to like, should I get you to do this one? You do 1024, you get x to the 512 and x to the 512. And that could split up again for one of them to be 216 and 216, which could split up again to be 128 and 128. And then 64 and 64, and finally 32 and 32, and then 16 and 16, and then 8 and 8, and then 4 and 4, and 2 and 2. Oh my goodness. So I guess what this question does, and the one right above, is sometimes we do a first level of factoring, only to find out we're not done yet. So the two things I ask you to check when you get your final answer. Check to see if you multiplied it out, that it comes out with the right answer or the same thing that you had before. And secondly, check if there's anything left that still has a common factor or maybe another difference of squares. All right, we have what? One question left. Determine the missing factor. How'd you do? To get the 4a squared, does it make sense that this would need to have a 2a in front? And if your last one's a 25 and this is a 5, does it make sense that it has to be a 5? And if your outside and inside have to cancel out, we have to have a plus there. So you have listed the homework from your textbook plus now that factoring worksheet that you have, that I gave you, that big handout of a whole bunch of factoring. It had some differences of squares on there. You now can do the whole thing as practice. It has common factors, it has every type of factoring mixed together. Really good practice.